Hello everyone. Welcome to my presentation. I am dealing with the subject Power Plant Engineering. In that topic is Steam Power Plant. The outline of my presentation is storage of coal, in-plant handling and furnace firing. In that first one is storage of the coal. Coal may be stored at the coal fields, at intermediate location near the plant and at final location near the boiler furnace. The store location and amount of the coal to be stored depends upon the availability of the space for storage, transportation, facilities, the amount of coal that must be weathered away nearest to coal mines of the power station, losses on storage and deterioration. Considering the above factors, the storage location, storage space and the capacity at each location is described in the following points. It is insurance against complete shutdown of a plant occurring from failure of a normal operating supplies to error. It permits some choice of the date of purchase of coal, allowing the purchaser to take the advantage of the seasonal condition. The storage method vary depends upon temperature, rain, wind condition at site. Tropical area needs special storage precautions to avoid spontaneous firing due to self-heating of explosion of coal. Type of coal also dictates the choice of handling and storage methods. During the storage, the coal undergo oxidation and deterioration due to chemical conditions. This effect is known as weathering of coal. The weathering depends upon the various coal methods, method of storing, total bulk of storage and exposure area, exposure of atmospheric air, sunlight, temperature, etc. Stored coal weather may ignite spontaneously. Weathering results some of the volatile matter to reduce the heating. Oxidation of coal may also undergo certain conditions heat to the coal at the point of ignition. Ventilation the piles can sometimes remove the heat and avoid the burning. The coal may be stored in the following methods. Stacking the coal in heaps. The coal is piled on the ground in open area up to 10 to 12 meter height. The pile top should be give a slope of the direction in which the rain may be drained off. The coal should be stored at a site located on solid ground, well drained, free of standing water, preferably on high ground not subject to folding. The sealing of stored pile is desirable in order to avoid the oxidation of the coal. Ash hat, coal dust and stored pile is desired in order to avoid the oxidation of coal. Bituminous coating are the materials commonly used for the sealing purposes. And second one is the stacking the coal under cover, storage under water, placing the coal in the burners. Storage under water, the possibility of slow oxidation and spontaneous combustion can be completely eliminated by storing the coal under the water. This is the cylindrical bunker. This is the storage from the coal which is withdrawn and supplied to the combustion equipment with little or no rehandling. This storage, also known as bunker, consisting of about 24 to 30 hours of coal requirements of the plant, and usually it is covered an area in the plant near the boiler furnace. The live storage can be provided with the bunkers and the coal bins. This is the cylindrical bunker. The bunkers are usually made of steel or reinforced concrete. From the bunkers, the coal is transported to the boiler garage, that is mechanical strokes. The following precautions must be taken during the coal storage for avoiding spontaneous combustion. Exposure surface area of the bunk storage should be minimum. Temperature is to be monitored very frequently in order to avoid exceed safe limits. If it limits the exceeds, the combustion takes place. The temperature is reduced by water spraying. Coal is packed layer by layer and moving roller over each layer. The top surface and sides must be covered with fine coal so that the internal coal is protected against oxidation. Coal should not be stored near the heat storage. If it is stored in the heat storage, combustion takes place. Underground or underwater storage is preferred for huge quantity over the long time because water is there. If combustion takes place, then the amount of heat liberated must be minimized. And the next one is the in-plant handling. The in-plant handling of coal may be shown in this block diagram. Coal from the coal mines is sent to the crushers. In the crushers, the coal is crushed into the small particles, and the crushed coal is sent to the vibratory screens. From the screens, fine coal is selected at specific gravity type cleaning system. In this system, the cleaning of the coal takes place, and the sink coal is rejected with high pyrite sulfur. If the specific gravity cleaning type and the float coal is collected and it is accepted. In the vibratory screens, if the coal is not finely crushed, again the coarse coal is set to the coal from the mines. Again the process gets repeated. That is coal from the mines, crushers, vibratory screens, fine coal, float coal, and it is accepted. If it is not accepted, the sink coal must be mixed with the chemical high pyrite sulfur because of the dust in the surrounding areas. If it is not chemically it is not filled with the sink coal, the pollution of that area is get increased. Coal preparation plant. This is the coal preparation plant. The uncrushed coal is sent into the coal crusher. So, in the coal crusher, the coal is get crushed and it is sent into the vibratory separator. In the vibratory separator, some of the coal is sent into the belt conveyors using the coal dryers. In that coal dryer, the coal is get dried and the hot gases is coming out of the coal dryer. For drying, the hot gases is sent into this. And after that, it is sent into the belt conveyor. From the belt conveyor, the fine coal is sent into the bucket elevators. From the bucket elevators, the coal is transported to the hoppers. In the magnetic conveyor, some of the coal is get rejected and it is set into the chute. And next one is the weighing and measuring. To weighing the quantity of coal, the following equipments are used. There are three equipments: mechanical, pneumatic, and electronic. Some of the equipments used are weighing lorries, hoppers, and automatic scales are used for the quantity of the coal. In the mechanical methods, work on a suitable lever system mounted on knife edge and bearings connected to the resistance in the form of a spring of a pendulum. In the pneumatic weighing machines, use the pneumatic transmitter weight, head, and corresponding air pressure determined by the load supplied. And the next one is the electronic weighing machine. In electronic weighing machines, make use of load cells that produce voltage signals proportional to the load supplied. As the cost of the fuel used is a major operating cost of the power plant, it is necessary to exercise proper control over total quantity of the coal used and to have an idea whether the coal supplied to the individual boiler is properly burned or not as per the load on the plant. The coal must be weighed at the unloading point and at individual stoker or by using pulverized hoppers. And next one is the furnace firing. This is the layout of the furnace firing. The following diagram shows the schematic layout of the fuel handling equipment of a modern power plant when coal is used. Coal is supplied to the power plant. Coal is supplied to the power plant in the railway wagons. After the weighing balance, the coal is then unloaded or into the unground hoppers. These are the hoppers. The wagon can be unloaded either manually or by through rotating wagon trippers. From the bunkers, the coal is lifted by the conveyor. From the bunkers, the coal is lifted by the conveyors to transfer the coaling towers, where it is delivered by the conveyor to the crushers. This is the crushers. The coal is then passed through the magnetic separator and screeners in the crusher, and it is crushed into the magnetic particles of 25 to 30 mm size for stroke firing and 10 to 20 mm when pulverized fuel is fired in the boiler furnace. This crushed coal in the latter case is milled to the fine particles and it is carried to the automatic weighers. After the automatic weighers, the coal is again sent into the transfer towers. From the transfer towers, it is sent into the boiler hoppers. So, this is the block diagrams of the furnace firing. So, in this class, we discussed about how the coal is get handled. So, the coal is get handled by the various methods. In my next lectures, we are going to discuss about the ash handling equipment and fuel burning techniques. There are 3 types of the fuel burning techniques and 4 methods of the ash handling system: mechanical, electrical, pneumatic, steam jet systems. And next one is the conveyors. From the conveyors, we are going to transfer the coal. And the coal is crushed and the pulverized. Burning of the coal is of 3 types: hand firing, feed firing and pulverized firing. Pulverized firing is the most important technique that is used because the coal is get pulverized into the fine particles which is used for the generation of the electricity. Most of the 50% of the generation of electricity is used by the pulverized coal only. And the next topic is the burners. From the burners, where the combustion takes place by using the burners. From the burners, we are going to know the classifications of the burners.